This is no ordinary aircraft. It's an electric vertical takeoff and landing vehicle, or eVTOL, and it could have a major impact on the aviation industry.
For the first time, you can build aircraft that are not only low cost, but also really safe and really low noise.
An aircraft that's going to create great utility for short distance trips. 30-mile trips can be completely carbon-free.
Vertical lift aircraft are nothing new. The first helicopter took off more than a century ago. Today, the helicopter market is valued at nearly $49 billion and is expected to grow to $74 billion by 2029. About 40% of helicopters are used as private air taxis, but high costs have kept them from going mainstream for the average traveler. The introduction of eVTOLs could change that. Helicopters introduced incredible utility to aviation, enabling new types of missions impossible for fixed-wing aircraft. The electric revolution is set to shake up the industry again as eVTOLs come on the scene.
Vertical takeoff and landing gives really an unmatched capability. And this is absolutely essential when we're dealing with mission-critical services, paramedical, reaching really remote areas. And this is the true value add of a helicopter. What happens when it becomes an eVTOL, it actually creates a new opportunity. And it also comes with some trade-offs as well.
Electric propulsion is the key element that completely changes how these aircraft fly.
With these vehicles, you can actually scale down the motors, and you can have many motors on these vehicles, making them not only just really efficient, but also really safe. The speed at which you can spin those propellers can be dramatically slower, and when you do that, you completely change the noise profile. And so these vehicles now, when they fly overhead, will be nearly silent to people on the ground.
Another advantage is that these new aircraft will be easier to pilot.
Much different than helicopters, and because of that, we think you have this new category that can be very attractive to young new pilots.
Operating costs are expected to be lower as well.
The fuel is going to be electricity, so the fuel is going to be relatively cheap.
Electric vehicles are powered by electric motors, which are much more simple than combustion or piston engines. That really enables much lower maintenance cost, which ultimately leads to much lower direct operating cost, which in turn transfers to low ticket prices.
Blade operates a rideshare service transporting up to 4 passengers between Manhattan and New York City airports for $195. eVTOL companies, on the other hand, are making big promises of pricing similar rides somewhere in the range of a premium Uber.
If you could imagine a trip from downtown Manhattan to Newark, those are typically a $100 type of ride.
Uber, which is investing in eVTOLs with startup Joby, estimates that operating a helicopter that flies 700 hours per year costs about $1,800 per flight hour. That would drop down to about $1,250 per flight hour if it flies 2,000 hours per year, a common target for how much eVTOLs will fly.
The key to get the cost per passenger down is to utilize the aircraft at a high level throughout the day. Our models suggest that we can make money and we can bring a great customer experience at that Uber Black level. As we fly more and more aircraft out of the same fixed infrastructure, we think we bring that down to an Uber X-like pricing.
The price point will also depend on the price of the actual vehicle. And so far, the value that we've heard from the market is between 3 million and 5 million. If you compare that to a helicopter that is currently serving that, they come in at, say, about 4.5 million, something like that.
But for now, the power and capabilities of helicopters are still superior.
Emergency medical services, search and rescue, it's law enforcement. For those type of missions, you need a certain payload and you need a certain range to be able to do it. At the moment, the eVTOLs are very far from achieving that payload range combination.
Over time, in the not too distant future, batteries will keep getting better. And as they get better, we will just continually upgrade the performance of our vehicles.
We should not try to replicate what a helicopter does with what we want from an eVTOL. eVTOL starts from a point of decarbonization. eVTOLs also start from a point of simplicity. So simplicity in design means it is simpler to maintain, simpler to certify, simpler to operate. So all of this creates then a very new market potential.
Airbus, which is developing its own eVTOLs, says they'll be used first for short-hop routes like air medical services, ecotourism, and passenger shuttle services.
Scheduled shuttle services, so the airport to downtown where it's really a time-saving, it is a predictive service, corporate shuttle services, right? Really taking to industrial parks and corporate locations. The beauty of these types of services is there is almost a very steady demand.
The eVTOL market is growing rapidly, with an estimated 200 companies attempting to create them worldwide. One of these is startup Archer Aviation, based in Palo Alto, California. It's taken a development approach that's oriented around the fastest path to market.
From the very beginning, we had a focus on commercialization because we wanted to build the most simple vehicle that could get that done, because that's the fastest way to do it, and we think the lowest risk way to get the vehicle certified.
The company's been spending the last 4 years developing a demonstration aircraft called Maker.
We call it our certification test bed. So we use that vehicle to work with the FAA in order to establish these rules to which we'll certify to. We also use that vehicle to prove out some of our core technology.
It just recently unveiled Midnight, its passenger aircraft intended for mass production. The vehicle is designed for a pilot and 4 passengers, with the ability to fly up to 100 miles at speeds up to 150 miles per hour. But it intends to service much shorter distances.
We actually don't think we'll be doing very many 100-mile trips because most of the demand will be replacing these 60 to 90-minute trips on the ground.
Designing and building an entirely new aircraft is expensive, costing millions or sometimes billions of dollars. To help finance its ambitious plans, Archer was one of the first eVTOL companies to go public via a SPAC in 2021, raising just over $850 million.
It's going to take a lot of money to bring these vehicles to market, but thankfully we timed it pretty well and we were able to team up with some great investors that have supported us.
United Airlines is investing in eVTOLs through 2 companies, another startup called Eve Air Mobility and Archer.
Archer has an incredible design in their Midnight aircraft. I think they're ahead of the competition in many ways, pursuing FAA certification. Embraer has spun out a company called Eve that is going to be focusing on their eVTOL initiatives and are very well positioned within the aerospace supply chain to be a leader in this emerging air taxi market.
They've really been more of a partner to us. We also formed a joint eVTOL committee where we're working on things like setting up our operations. We're working on how to develop Archer's maintenance plans. They even helped us in our design as we thought about how to build a vehicle that not only could be scaled, but also operated.
United and Archer recently announced plans for a 2025 launch of air taxi service in New York City.
We're going to be flying from downtown Manhattan at the heliport that exists there already to Newark Liberty International Airport, which is one of United's main hubs. It's a route that millions of people already take every year. People are already going from Manhattan to Newark. And we know there's demand because we see it in rideshare every day.
We're going to add cities, and you'll hear more from us in coming months around initial launch cities. But think about the congested hubs we fly into in San Francisco, in Chicago, in Houston, and in New York, LA. Those are the cities that are going to benefit, where the distance between the downtown and the airport is not really that great, but because of congestion, eVTOL is going to provide great utility.
In addition to operating a rideshare service, Archer is also selling its aircraft.
We announced last year that United Airlines will be buying some of our planes. Not only does it help us finance the vehicles and finance the building of this company, but it also adds an element of safety and trust into the equation.
But to deliver on its promises, Archer needs to scale manufacturing significantly. So it's teamed up with automaker Stellantis, which has promised to help Archer with manufacturing and invest up to $150 million in the effort.
They have a lot of experience in taking a product that's making thousands of vehicles and really scaling that up to hundreds of thousands of vehicles. Stellantis also has a management team that has some aviation experience.
The manufacturing angle is certainly something that the eVTOLs will need to look at. The scale of the manufacturing is imperative to be able to achieve a lower price point.
We're actually nearly complete with our low-rate initial production facility in California, which is right next door to our headquarters in the Bay Area. We're doing that to build our first 10 aircraft, which will be used for the certification process.
Archer recently announced that it'll build its first large-scale factory in Georgia at the Covington Municipal Airport.
The Covington manufacturing facility was designed to be able to launch with 250 aircraft built within its first year, but then really scale up from there. So the first phase of the production really can take us up to 650 aircraft on an annual basis.
But there are some big hurdles that Archer and eVTOLs in general must overcome to get to market, the largest being regulatory. Certifying aircraft is an intensive process that can take years, even for proven designs.
The Airbus H160, that one took from program launch to delivering it about 10 years. Bell is developing a heavy helicopter, the Bell 525. That one was launched in 2012 and it is not yet certified. But perhaps the most interesting one that is more, in my opinion, closely linked to the eVTOL designs is Leonardo's AW609, is a tilt rotor. Now that program was launched in 1996 and it is still not certified.
Archer says it's been working closely with the Federal Aviation Administration to expedite the process.
We've agreed to a lot of the rules with the FAA, and we're going to start working now towards the testing part, where we are validating that we can meet those rules and meet those standards. The goal to get through certification is really centered around the end of 2024.
Public acceptance is also critical for widespread adoption.
We have seen programs being affected by public acceptance. We had a fatal crash by one of the large helicopters in the North Sea, and that helicopter is no longer operating in offshore service because people refuse to fly in it.
And while eVTOLs could offer some advantages, traditional helicopters are also looking to leverage the benefits of electrification.
Robinson takes a large market share in the corporate private sector, and they have recently completed test flights with its R22 with electric engine.
As we're developing our eVTOL, all of this technology is then advancing the decarbonization of our helicopters. We're testing on eVTOL and bringing it back to the helicopters. So the entire improvement of the overall product line is advancing.
Infrastructure is another bottleneck. eVTOLs could leverage existing helipads, but new vertiports will need to be built to accommodate the big demand that companies are projecting.
If you look at most of the modern cities today, they're quite built up, like New York, like London, like Hong Kong. It is going to be quite tricky to make room for this kind of mode of transport.